gets to work. I'm carrying on with question 1 on page 394, I believe, 354 rather, and this is the transformation of the graph of y equals x cubed. I've done the previous one, y equals x cubed plus 4, where I just raised it 4 units in the y direction. Now I'm going to go for this function again, y equals some function of x, in other words x cubed, and I'm going to go y equals af of x, and I've been told in the question that a is worth 3, so I'm going to stretch the y coordinates for each coordinate by multiplying it by 3, and that should stretch this in the y direction by 3 by a scale factor of 3. So that's the point 1, 1, because 1 cubed is 1, so that's deliberately accurately drawn there, and minus 1 of course. So if I go 1, 1, for example, then I multiply the y coordinate by 3, I end up with 1, 3. Likewise, in the negative direction, it will be 1, minus 3. Alright, so I'm looking at a very, very pointy little graph. It looks a little bit like this, like that, passing through 0, 0, and then goes up again like that. They're supposed to be like a curve, but it's been so stretched in the vertical direction, it's almost becoming like a straight line almost, but I'm exaggerating that. But it's meant to have a bit of a curve on that, so it curves up, moves towards 0, 0, and curves back up again. So the transformed graph will be y equals 3x cubed, alright? And of course the a was 3, so I multiplied the y coordinate by 3. So 1, 1 becomes 1, 3 as an example, okay? Still passes through 0, 0, because 0 cubed is still 0, and 0 times 3 is still 0. So however I transform the x cubed, whether multiplied by 6 or 7 or 2 or 3, it always passes through 0, 0. So that's been transformed using the function y equals af of x, and the a is 3, hence I've gone from y equals x cubed into y equals 3x cubed. Alright, that's that one. Oops. Right then, this is the graph of y equals sine x. I've got to transform sine x by going y equals sine x plus 4, and that's raising the entire curve 4 units up in the y direction. Remember, I'm transforming using vector 0, 4. So 0, 0 becomes 0, 4, 1, 2, 3, 4, there. So effectively, that is where the graph will start, and it will peak there on 90 degrees, and come back to 4 on 180 degrees, then drop 1 unit on 270 degrees, and then back to 360 there. Let's just get this equation out of the way, rub it out, and then hopefully we can... won't let me do it, never mind, let's just try and draw it in. And this will go 1 unit in the negative direction and then come up again. Alright, so this is effectively my coordinates of my transformed graph y equals sine x plus 4, and hopefully it will let me draw it. Let's have a look. Come down, up, round, down and back. Okay, and that's a complete sine wave there, and I also did half a sine wave in the negative direction because it looks quite nice. Okay, effectively I raised the graph 4 units in the y direction by lifting the graph up 4 units like that, plus 4, using vector 0, 4, okay, as usual. So it can be done with straight lines, it can be done with regular quadratic curves, quadratic equations, quadratic graphs, it can be done with cyclic functions like this one here. Now, this one is going to be transformed into y equals 3 sine x. Remember, the basic function is y equals function of x, and here it's going to be y equals something times the function of x, and of course the a is going to be 3. Alright then, so here we have the x coordinate staying put and the y coordinate being multiplied by a scale factor of 3. So that's the point 0, 0, 0 degrees, and the sine of 0 is 0. 90 degrees, the sine of the 90 is 1 exactly. So if I'm going to multiply the y coordinates, in other words 91 by 3, they end up with 93. Alright, they end up with 180. Going back to 0 again, because 3 times 0 is 0, and so I'll get a peak just there on the 90, and minus 1 times 3 will be minus 3, so if I put a minus 3 there, you'll be able to see it. And let's take a look. Minus 1 times 3 will be minus 3 here as well. Anyway, let's just do the right hand side. If I draw it in carefully, I find the graph peaks on plus 3, comes through 180, 0, 270, minus 3, and back up to 360 again. Alright, so effectively I've stretched the graph times 3 in the y direction. Alright, so 91 becomes 93, 270 minus 1 becomes 270 minus 3. If I wanted to continue this graph, how would it look? It will peak, in fact that should be just there in fact, if I was being accurate about it. This should come all the way down here, trough on minus 3 and go back up to 0 on minus 180. So that's minus 180 degrees, and that's minus 90 degrees. Of course it should be on this side of the line, but I want to keep it out by the curve. Alright, so either way I've produced a valid times 3 stretch in the y direction, and that's really good. That's fine, it's a lovely looking graph. Now my next job is to try and do exactly the same thing to cosine. It's a little bit more difficult to get your head around this one, but the same thing again. I'm trying to go for y equals cosine of x plus 4. That's raising the whole graph 4 units, so let's just try and do that. 1, 2, 3, 4. Let's just put a 5 there, like so. Essentially lift it 4 units, so I'm going to go from 1, 2, 3, 4. Let's have a look. 1, 2, 3, 4. Start here, and my 90 would be here. My 180 would be here, I believe. Let's just check. So down here, 90 is there, 180 is here, 270 is here, and 360 is here. So let's just draw in half the cosine wave. So please work. Yes, that's not bad. So there's that part done, transformed. If I wanted to go and work in the negative direction, go up 4 units, 1, 2, 3, 4, that's there, and this one as well, 1, 2, 3, 4, that's there. If I continue my curve, I'm going to get something like this, and there it is. So that's my graph of y equals, that one is, by the way, y equals cosine x plus 4, and that's the regular blue y equals cosine x, and all I've done is just raise it 4 units using vector 0, 4, just like all the other functions. Alright, wish me luck with this one. I'm trying to go for y equals 3 times the cosine of x, essentially leave the x value alone and multiply the y part of each coordinate by 3. So 0, 1 becomes 0, 3. So if I put a 3 there in red, it'll be consistent. There you go. So I want a coordinate there, and that's that. And 90 is going to be 90, 0 become 90, 0, because 3 zeros are still 0. And 180 minus 1 become 180 minus 3. So I've got a coordinate then. Of course, that's going to be minus 3. And 361 will become 363. Again, I'm multiplying the y coordinate by 3. Just draw this half in, and that should be fine. So 90, 0, 180 minus 3. Coming up carefully to... Oh, I've made a mistake here. Yeah, I've got to pass through 270. Made a mistake. Pass through 270 and just peak on 360 again. So pass through 270, 0, and up to 363. And there it is. Climb back down to minus 90, and this should be minus 3 on the minus 180. I think that's perfectly good. So what have I done? I've stretched the graph multiplied by 3 in the y direction. I've stretched 180 minus 1 to 180 minus 3. So effectively what I've done is gone up 3, down 3, up 3, down 3, produces this lovely stretched graph in the y direction. Not dissimilar to the way sin x works, but it's a lot easier to draw the sin x one. Just seems an awful lot easier to work with sine than cosine. But that's it then. And that was again, like I said, a stretch in the Y direction by scale factor 3. And I'll stop the video there and probably get 2 videos out of it because it's a little bit long. The pen was a bit glitchy, it's all a bit slow. I hope it works out okay and that you get some sense out of this very difficult topic. Thank you.